Okay, guys, so we've talked a little bit about solutions. Today we're going to talk about solubility. And solubility is just a measure of how much of the solute you can dissolve in the solvent. And specifically, it's how many grams of solute you can dissolve per 100 grams of solvent. So here you see a little chart that's going to help us with this. We've got three substances: potassium iodide, potassium nitrate, and sodium chloride. And so our x-axis is temperature, so we're changing the temperature and we're looking at how many grams of each of these three things we can dissolve per 100 grams of water. So the label is actually grams per 100 cubic centimeters of water, but a cubic centimeter of water is a milliliter, which is also a gram for water. So if I have 100 grams of water, for example, it looks like at 60 degrees Celsius, I can dissolve about 40 grams of sodium chloride. But I could dissolve a whole lot more, looks like maybe 110 grams of potassium nitrate. So one of the things we notice here is that solids are usually more soluble as temperature increases. And that's simply because the particles are moving around a lot faster. So if I have 30 grams of sodium chloride, and I put it into 100 milliliters of water and I mix it up, what we create is what's called an unsaturated solution. And if I look at the chart, here's why. Let's assume we're at about room temperature, which is about 25 degrees Celsius. So right about here is where we are, about 25 degrees Celsius. So it looks like at 25 degrees Celsius, we're going to call it about 36 or 38 grams of salt could dissolve, okay, at 25 degrees Celsius in 100 grams of water. So what we have here is an unsaturated solution. And what an unsaturated solution will look like is it's just clear because all of the ions in that 30 grams of sodium chloride have dissolved. Now, if I go up to 40 grams and I keep the temperature at room temperature, 25 degrees Celsius, and I keep the same amount of water that I'm dissolving the salt in, we already said that only about 36 grams, that's all we could dissolve at that temperature. And so the other 4 grams, so 40 minus 36 would be 4. So the other 4 grams should just fall right down to the bottom. So this is what's called a saturated solution because we have the maximum amount of dissolved salt that we could have, and the rest should just fall down to the bottom. Okay, so a couple definitions, we've already mentioned them, but let's put them in our notes. An unsaturated solution means we have less than the maximum amount. So like, at room temperature, 30 grams would be under the line, so less than the maximum amount that we should be able to dissolve. Saturated means we have the maximum amount, so we're right at the line. So at room temperature, 25 degrees Celsius, we're going to call that about 36 grams. And then supersaturated means we have more than the maximum amount dissolved. So here's how that works. Basically, if we have, let's switch up substances and go with, let's talk about potassium iodide. So let's say I'm at 60 degrees Celsius for potassium iodide. And I put, let's just keep it simple and say 190 grams of potassium iodide in 100 grams of water. Would that be saturated, unsaturated, or supersaturated? Okay, so hopefully you're thinking to yourself or saying unsaturated because I'm well below the line. At 60 degrees Celsius, I expect to be able to dissolve like, 230 or so grams of that particular substance, right? Okay, so it's unsaturated. How much would I have to cool it down in order for it to become saturated? So we would have to cool it down all the way to this point where we're on the line. So if I still just have 190 grams of potassium iodide in my solution, I would have to cool it all the way down to, I don't know, I'm going to say 30, maybe 35 degrees Celsius for it to be saturated, okay? Now, if I cool it down some more, let's say I cool it all the way down to 15 degrees Celsius, one of two things is going to happen. What we expect to happen is that because we're only supposed to be able to dissolve about, I'm going to say 150 grams at that temperature, the difference, which would be 40 grams, would simply come out of solution. It would precipitate. It would, probably just fall down to the bottom. It would crystallize and then fall down to the bottom as a precipitate. And that may very well happen. But the other thing that might happen is just by happenstance, just by, just sort of randomness, the potassium iodide ions never collide with each other often enough to form crystals. And if you never get that crystal formation to start, then it just sort of never happens. And the ions just sort of stay in solution, even though we have an extra 40 grams for that temperature. And so that's a supersaturated solution. Okay. So, and a lot of times, all it takes for that supersaturated solution is one little crystal to start forming, and then the whole thing has something to attach to. It's called a seed crystal. So if you get just a few little ions that start to precipitate, a whole bunch more will attach to it, and all of those, in this case 40 grams, would come out of solution as precipitate. So I've imported a little YouTube video of this happening with sodium acetate. So let's go ahead and take a look at that. I did not do this. This is somebody else's video. Okay, there we go. So this is going to be sodium acetate, and let's go ahead and play this. You'll see that it's clear at first, but it's a supersaturated solution. And he's just going to put a little seed crystal. So he has more sodium acetate dissolved than he should have, but at that temperature. So then he just puts in a little spatula with a little bit of sodium acetate at the tip, and notice that sodium acetate then acts as a seed crystal, and the other sodium acetate will attach to it, and now we have all of our extra sodium acetate coming out of solution. So it's a really cool demonstration, and we can do it in class. It's a little bit unreliable, so it doesn't always work, but there you go. So that was a supersaturated solution. Now it's just saturated, if that makes sense. Okay, a couple questions here. How many grams of Ki could you dissolve in 100 grams of water at 30 degrees Celsius? So let's, we've got 100 grams of water, 30 degrees Celsius. All right, so here's 30 degrees, right? We're talking about Ki, potassium iodide. So all I have to do is kind of just follow this 30-degree mark all the way up to the line for Ki, which is right there. And it looks like at that temperature, I can dissolve maybe about 100 and I guess that's about 180 grams of Ki. Okay, hopefully that made sense. All right, how many grams of potassium nitrate would you need to make a saturated solution in 200 grams of water? So let's be careful here. So 200 grams of water, that's twice as much water. So what I can do is use my chart to figure out how much I would need in 100 grams of water, and then we'll just double it, right? So at 45 degrees Celsius, and we're talking about potassium nitrate this time, so I just follow it up, and it looks like it hits at about, I'm going to call that 75, right? So 75 grams of Ki, but because this is per 100 grams of water, and the question is asking me about 200, I'm simply going to multiply by 2, and so that should give me about 150 grams of potassium nitrate. Okay? All right, let's take a look at this one. See if you can pause and answer this one on your own. If 100 grams of potassium nitrate is dissolved in 100 grams of water at 75 degrees Celsius, is the solution unsaturated, saturated, or supersaturated? Okay, so we're at 75 degrees, and we have 100 grams, which is right here. So that's below the line for potassium nitrate, so that you should have said is unsaturated. Okay. What if the same solution we're cooled to 45 degrees, but no solid crystallized. So if we take this all the way to 45 degrees, it looks like now we're above the line. So if no solid crystallized, that means we're above what we should have at that temperature. So hopefully you said that this one would be super saturated. And we'll do some more problems with this next time.